Howdy, howdy. This is Miss Becky here. Notes for IXL Precalculus Section M5. I'm going to do my best with this here setup. I'm a little freaked out by all this technology. Anywho's, as always, if you find a mistake, let me know. There could be some extra credit in there for you. And as always, spelling never counts. So what we're doing here is you're going to be asked to find the trig ratios of the right triangles. And so just to go over, we've got so, ka, toa. And again, that's the sine, which is the opposite over hypotenuse. You've got cosine, which is adjacent leg over the hypotenuse, and the tangent, which is the opposite leg over the adjacent leg. Then over here in green, I have written down the reciprocal of those. And this one is cosecant, which I can remember let's see if I can do this. Let's do this in blue. Okay, so this one has a C, this one has an S. So if this one starts with a C, use the one that starts with the S here. That's the way I have to do things in my brain. So cosecant goes with sine, they're reciprocal. So you would just flip hypotenuse over the opposite. And secant is the reciprocal of cosecant, and you would just flip it, hypotenuse over adjacent. And cotangent, that's the easy one because it's the reciprocal of tangent. So with that in mind, going on here, so what we're doing, you got to be careful. You're trying to find the tangent of angle G. So that's this angle right here. And so the tangent is opposite over adjacent. And so the opposite leg is 35. Come on, technology, don't fail me now. 35 over adjacent is 12. And then if you could reduce this, you would reduce it. And remember that the hypotenuse is right across the street from, come on, technology, from the right angle. So if you could reduce that, then you can reduce it. And I don't know, let's see, proper fraction, improper fraction, or whole number. Okay, so they want it as a fraction. All right, so now over here, you're looking for the cotangent of angle R. So we're looking at that angle right there. Cotangent is adjacent over opposite. The adjacent leg to angle R is that leg right there, 5. Zoop. And the opposite leg is 12. Ta-da! So this is all, I mean, you cannot reduce that. Okay, moving over here, we're going for angle I, which is down here in this here corner. And we want the CSC, which is the cosecant. There's a truck going by, or an airplane. Sorry, I have to have my window open. I need noise. CSC, which is hypotenuse over opposite of angle I. So the hypotenuse here is 97. And the opposite leg is 72. Again, that can't be reduced. So now this one, moving on to this one, we want the sine, and this is pronounced sine, not sin, of angle W, which is this one right here. So we want the opposite leg, which is 24. And the hypotenuse, which is 26. And obviously we can reduce that one. And that's going to be 12 over 13. Okay. Alrighty, moving right along. So now we're looking for the secant of angle R, which is this little puppy right there. And secant is over here. It's hypotenuse over adjacent. Hypotenuse looks like we got 65. And adjacent leg, is that a 33? 33. Bam, not so bad there. Okay, number 6, we're looking for the cosecant. Cosecant. This one. Of angle W. This one. All right, so we've got the hypotenuse, all shnikes. We have no number here. What are we going to do? Any ideas? Okay. What we're going to do, choose another color. Let's do orange. Okay, so we can use the Pythagorean theorem if we'd like to. We'll do it down here. A squared plus B squared equals C squared. I really feel weird talking to myself. At least the dog's in here. Okay, so the A and the B, again, are the legs. These are the legs, 3 and 4. So 3 squared plus 4 squared equals C squared. You always wondered what you're going to use this for. Okay, 3 squared is 9. This is 16. And this is still C squared. All right, this is 25 equals C squared. Then when we take the root of both of those, lo and behold, we get C equals 5. So we know this leg is 5. Okay, so now we can do it. Cosecant of this angle here is hypotenuse, which is 5, over the opposite leg, which is 4. Is that right? 5 over 4. Angle W. We're doing cosecant, which is the hypotenuse over opposite. Yeah, I think that's right. Okay, so there we go with that. Okie dokie. So this last example here is we got to find the sine of angle R. So come on, technology, work with me. Down here. So that's the opposite leg over the hypotenuse. Opposite is going to be 4 times the square root of 87 over the hypotenuse, which is 8 times the square root of 29. So what you need to pay attention to is you want to see if you can reduce this. Remember, numbers go with numbers and radicals go with radicals. So we know that this can reduce. So this becomes 1/2. So this one here is a little bit suspicious. So you can start breaking it down into prime numbers. So we could break that one down into the square root of 3 times the square root of 29. So if you didn't know, you can just start checking it out, like divide 87 on your calculator by different things. And obviously it's not going to be a 2, it's not going to be a 5, no even number like that. So there's a little 3 trick, actually. If you add 7 and 8, that equals 15. 15 is divisible by 3, so I know that 87 is also divisible by 3. So now we have renamed 87 as the square root of 3 times the square root of 29. And since this is, come on, technology, this is on the, still in the numerator. So this square root of 29, that is horrible, cancels this square root of 29. So what we are left with is, on the top, we have the square root of 3 over 2. Not as bad as what we thought that it was going to be. Anyway, that's all I have to say about that. Let me know if you have any questions or if you find any errors. And you guys have this, and continue with your day.